If you're actually working diligently, I might not count this quiz as anything. I had to collect it in my last class because they were being goofballs. My other classes I didn't collect it, so I just went through everything with it on this. But there's a quiz right after this that will count. So. All right, on this, just running through this, let's go through it sort of quick, and then we'll jump onto the homework and then onto the other quiz. We're going to try to hurry a little bit. Name the vertex of angle 3. When you're naming a vertex of an angle, should just be a what? One letter, a point. So what's the if this is angle 3 right here, what's the vertex of that angle? Good, it's C. Name a point in the interior of angle ACB. Well, I just traced angle ACB. When I traced angle 3 there, they were the same angle. Name a point that's on the interior. Point G. Now, did everybody know that before I extended the sides out? The sides extend out forever, even though it wasn't shown in the picture originally, so point G. How about point D? Is it on the interior of that angle? No, it's actually on one of the sides of the angle. How about point B? Is it on the interior? No, it's on one of the sides. Name the sides of angle BAC. BAC is this angle. Everybody see that angle instead of the other one now? First word that should come out of anybody's mouth when they tell me one of the sides is what, Allison? A ray. All right? They're both supposed to be rays. So I know I'm going to start off with the ray symbol. Give me one ray that's one of those sides.
AD.
Ray AD. Everybody agree with that? Start at A, go out through D. Is that one of the sides?
Yeah.
What's the other one?
Ray AC. Isn't that where it goes to?
Say it again. I thought that
AC.
AC. Or, no.
AB.
Yeah,
That's this one, right? Now, when Allison's saying ray AC, what ray did she name again? The same one that she named the first time. Ray AD and ray AC are actually the same ray because they have the same starting point and they both go out in that direction forever and ever.
So that's what
Oh, I
So-
thought that one up there was a.
So another way you could name this one would have been ray what?
AC.
AC. If you wanted to name that a different way. Name an angle with vertex at B that appears to be acute. B is right here. So we want that as our vertex. What should be the first word that comes out of everybody's mouth this time?
Angle.
So we put the angle symbol down. What do we know? Any angle that has its vertex at B,
Needs to be the middle letter.
B has to be the middle letter. So if you say QST, is that going to work?
No.
No, because we know B has to be the middle letter. So now name me an angle.
ABD.
I heard ABD. Give me another one.
DBC.
DBC. Somebody tell me if we're getting any wrong here. I think there's one more, isn't there? ABC. Now, a lot of you might not have ABC. You thought, well, I don't know if that's a acute angle or not. Let's erase some of this. My eraser quit working. Anybody have a good way to tell if that's an acute angle or not? Measure. You didn't have a protractor, what could you do? Yeah, Don. How can you tell if it's a right angle? Yeah, if it has the right angle symbol. What if they didn't give us the symbol though?
Put the corner in your paper and see if it's not right.
If you got a piece of paper, all right, everybody watching, because I know there's one of these on a test or a quiz that we got coming up here before too long. You got a piece of paper. What do you know about all four of these angles?
Right.
They're all right angles. If I wanted to see if that angle right there is a right angle or not, I take one of the corners, lay it on the vertex, and match up one of the sides. See how my edge of my paper matches up with this side? Now, Does the other edge of or the other side over here match up with this side of the angle? No, the edge goes out farther, right? So what's that tell us about that angle?
It's cute.
It's acute. It's less than 90 degrees. Next one, if BC bisects. Help me out before I walk back over there. What's bisects mean?
Splits it in half. Or
And the
equal
two
parts.
congruent segments.
Two congruent segments?
Or rays.
Rays?
Angles.
Angles, thank you.
Angles.
So,
Wow.
so BD, that right there, bisects angle ABC. That's this angle. So what's that tell us about these two angles?
They're pretty equal.
They have to be equal, they're congruent. So I'm going to go ahead and mark them. Congruent. Somebody read this part to me.
Measure of angle ABD.
Everybody knows that, right? Anytime you see that little m, measure of whatever comes next. So measure of angle ABD.
2x.
ABD is this angle right here. However you label your angles and stuff, that's up to you. Figure out a way that makes it easy for you. If you don't like the way I do it, then do it some other way. This time I'm going to draw an arrow and point at that angle and write 2x plus 3 in there. Read this one to me.
Measure of angle DBC.
BBC, that's this angle right here. And it's 3x minus 13. And they want us to find the measure of angle ABD. On some of these problems, if I drew this, told you this was x, this was 3x, told you this whole thing was 50. What equation would you set up?
X plus 3x equals
Does everybody see that? Michael, do you see that? X plus 3x, this angle plus this angle should equal the whole thing, right? That's one way you could set up an equation. Probably the hardest thing in geometry as we go through this year, the hardest thing that Wade's going to have to do is figure out what equation to set up for each problem. Because everyone's going to be a little different, all right? You're given something like this plus this equals the whole thing. Can we do that on this problem?
No.
Why can't we do it on this problem?
Because we don't know what it'll equal.
We don't know the whole thing this time. All right, so we can't set up that same kind of equation for this certain problem. So you got to come up with some other equation that you can set up. In this case, what did we know about these two angles?
They're equal.
They're equal, they're congruent, right? If they're congruent to each other in algebra, that means that they are equal to each other. So this expression right here should equal what? The other one. So what equation can I set up?
2x plus 3 equals 3x plus 3. Or, yeah.
2x plus 3, this angle
Equals
should
3x.
equal
3x minus
3x minus 13. Then you solve that. Subtract 2x on both sides. Guarantee on the quiz we are going to take here in a few minutes, there's a problem that deals with angles like this on it. That's x minus 13. Add 13 to both sides. If I could write sideways. These cancel out. X equals what?
60. But that.
Is that our answer?
I don't know.
Now on the quiz, they're going to ask you to find the variable and find an angle, so you'll have two answers. In this case, they just said find this certain angle. Well, what was angle ABD?
2x plus 3.
Right here, right? So in place of x, what am I going to substitute in there?
16.
How many people did I lose at that point? Paige, did I lose you? Anybody? Nora, did I lose you? Wade, did I lose you? Okay, we're at Wade.
I guess sometimes when I forget how we set these things up.
All right, and that's what I said. This is probably the hardest thing is getting the equation set up, right? Because Mr. Griffin or Mr. Harrison or whatever other math teacher you had before now, they're spectacular and they taught you for sure how to solve every algebraic equation, right? So the only problem you're going to have now is you got to learn from me and maybe I'm not so good at telling you how to set them up. So what you got to do, every problem's going to be a little different. There's no way that I can say, hey, this problem's always going to be this way. This problem's always going to be this way. That's the nice thing about math when you're in like 4th grade, right? You have a big long worksheet of problems and you did the same thing every time, right? And that was easy. Now it's not that way once you get up to higher level math. So you got to look at the problem and say, okay, what do I know about this? Up here, we knew these 2 angles and we knew the whole thing. So we'd say this angle plus this angle has to equal that whole angle. Okay? Here we knew that these 2 angles were equal to each other. So we just set this equal to that. Now maybe next time they tell you this angle is 5x and they don't tell you this one. And you say, well, if they're equal, this one has to be 5x also. But you can't set up 5x equals 5x. Alright? Because that's not going to do anything. So you'd have to say 5x plus 5x, and they'd have to tell you what the whole angle is. Does that help any? Yeah. And I went through it sort of quick. And so it's just different all the time. You understood all this, though? We do the math here. What's 2 times 16? 32 plus 3. So the angle is 35 degrees. That's this angle, 35 degrees. What's this angle over here?
35 degrees.
35 degrees. A little tougher question. What's angle ABC?
70.
70. How'd you get that?
Add together.
Add them both up. Add them both together. It should be the whole angle there. The last one. On this last one. Wait, were you writing that down?
Yeah.
Sorry.
Let me know. I got it.
Okay. I just happened to remember as I started erasing, I seen you writing, and I thought, I'll probably just erase something that he was writing. On the last one, if point P is in the interior of angle MON, well, where's angle MON?
You have to draw it.
Oh, so you got to draw it. So I come up here and I draw. I'm going to change my ink color here because I don't like the green that I got. I'd rather have red. If I draw this angle, what's this letter?
N.
Everybody agree with that? Everybody know where we got that from, this angle right there? Where's point P at? Right here?
On the anterior.
Inside. So here?
No.
Somewhere in here, right?
Yeah.
I don't know where, they didn't tell us, we'll put it in there anyway. Point P is on the interior of angle MON, so we got that part. Measure of angle MOP, there is no angle MOP.
Oh, we gotta draw it.
Draw what? From where to where?
O to P.
O through P. Now we have an angle MOP. So the measure of this angle is equal to, somebody read this to me.
Half the measure of angle and
So half the measure of that angle. So what's that telling you?
It's a bisector.
It's telling us that this is a bisector, and what do we know about these 2 angles? They have to be congruent to each other. So let's go over here and look at this. Angle PON is congruent to angle NON. PON, that's its bottom angle.
No.
Is that congruent to MON?
No.
That doesn't even make sense no matter what they told us, right? This angle, this smaller angle here can't be the same as the angle that's around the outside of it. So that one's got to be wrong. Angle MON is acute. This is the one that usually gets everybody.
We
Is
don't-
angle MON acute?
We don't know yet.
We don't know.
Does it look acute? Yeah, it looks like it, but when I drew the picture, did they tell me how to draw that angle? No, I just drew some random angle up there so that we could have an angle MON. Could I have just as easily have drawn that angle for angle MON? Yeah, they didn't tell us what to draw. So when you see something like this, don't decide that, yeah, that's an acute angle because that's what I drew. Because if most of you, if you drew this on your paper, I can about guarantee if I walked around and looked at your paper, what kind of angle would you have? You'd have a right angle. And then they say, is angle MON a right angle? And you say, yeah, that's what I drew. No, they didn't tell you to draw that, so you don't know for sure that it's supposed to be right. OP bisects angle MON.
Yeah.
Is this a ray that bisects that angle?
Yeah.
Looks like it. That's what we came up with. Why we marked these. Let's make sure on this last one. Angle MOP is greater than angle PON. What do you know about it? They're the same, so that one doesn't work. So the only one that works is C. No, that make any sense whatsoever? Are you lying to me just so I'll quit talking to you and leave you alone?
I'm serious.
All right.
What did you say?
That's why I didn't ask you, Albert.
That was Wade.
That was Wade.
Oh, that was Wade. Sorry, Albert. That's why I didn't ask you, Wade. That's what happens when you get old. I can't. I hear general directions.
Kind of ruined the real picture.
Yeah, it did. So I probably should not say a bunch of jokes, should I? That's not what I want. On the homework, page 34. Somebody did. Yes, no, maybe.
I'll spit the same one that I got.
Oh, you got twins. Page 34, questions. Who was it was in here? Oh, it was Caleb. Caleb probably won't ask any questions because he knows what's going to be on this quiz coming up. And he doesn't want to help any of you out. He told me during intervention, I ain't helping none of those guys out. 34 questions. None? Just take this quiz? Oh, that's not a good idea. Better ask now. 34. I'm telling you, Caleb's being mean because he knows what's on this quiz and knows which questions he should ask, and he ain't even gonna bother to ask. Problem 34. Every single time you're doing a problem for the whole year in geometry, if it's a problem like this and it has a picture, very first thing you have to do on your paper, draw the picture. Draw it out so you can work stuff out and write stuff down on it and think it through. If you don't do that, you're never ever going to understand any of this stuff. Somebody read the directions. The directions, not problem 34, but the actual directions. What's it say? Nobody can help me out? So we're going to waste a bunch of time. All right. You got 20 minutes to do this quiz. Time's starting right now. Since we're wasting time.
Wait, the directions?
Directions.
Okay. In the figure, ray y, x, and ray y, z are opposite rays.
All right, stop right there. These two are opposite rays. What's that tell us?
They're 180.
They form a straight angle, so all of these together should combine up to be 180 degrees. All right, go on.
Ray yu bisects angle zyw.
What's that tell us about these two angles?
Congruent.
So let's mark them congruent. Everybody understand that much so far? Wade, that makes sense so far? These two are congruent, right? Because that was bisecting it. What's the next thing say?
And ray yt bisects angle xyw.
Now, can I mark this like that?
No.
Why not?
That means they're all
That means all four of them be congruent. We don't know that. We know these two are the same. We know these two are the same. So maybe put 2 tick marks on there. You could put 2 arcs on it, however you want to mark it, just so that you know that they're different. That's all the directions, right?
Yeah.
Now let's jump to problem 34. What's problem 34 say?
If measure of angle ZYU equals 8p minus 10.
ZYU,
Yeah.
so 8p minus 10, that's that angle with this angle right here. All right.
The measure of angle UYW equals 10p minus 20.
Now, before she says anything else, what do we know about those two angles? So what equation can we set up right now?
8p minus 10 equals 10p minus 20.
Those two have to be equal, right? Now, if they tell us this whole angle in her next statement, then we could say this plus this equals the whole thing, and we could set up that equation. If they don't, then we're just going to set this equal to this and solve that equation. What do they tell us next?
Find measure of angle ZYU.
So they didn't tell us the whole angle, did they? So what equation am I gonna set up?
8p minus 10 equals 10p minus 10.
I'm gonna solve that real quick. Subtract 8p on both sides. These cancel, you're left with -10. Really watch your signs, don't lose that negative there. 2p minus 20. Add 20 to both sides. End up with 10 equals 2p. Divide by 2, what's p equal?
5.
Now, again, on the quiz, that's going to be part of your answer. This time, they didn't care what p equaled. They want us to find ZYU, which is that angle. So what do I have to do?
Plug 5
Into the expression there, right? Into right there. So 8 times 5 minus 10. What is 8 times 5?
40,
Minus 10.
30.
So the measure of that angle is 30 degrees. What's the measure of this angle? 30 degrees. Could we find these other two angles if we wanted to?
Yeah.
Yeah, we know all of them together add up to 180 and we could go through all that. I don't feel like doing that right now. Other questions? 54? See, Caleb decided that he wanted to be nice. Or somebody mad at you, Caleb, they give you a dirty look or something. No, there's a problem just like that one that we just got done doing on the quiz. The other ones that are on the quiz are like this one. After I get done doing this problem, I think it's like this one. After I get done doing this problem, we're going to take the quiz. -2, 0, 6, 4. We want to find the length of the segment between those 2 points, and we want to find the midpoint. So if I was to graph those 2 points, and I'm just going to do it real quick, -2, 0, somewhere about in there, 6, 4, somewhere about in here maybe. So we're trying to find the length of that segment, and then we're also looking for the coordinates of the point that's right in the middle. Which one do you want to do first?
You're doing problem 53, by
Oh, am I?
the way. Yeah.
Oh, well, does it matter really?
No.
Same kind of problem, right?
Yeah.
No, I'm not changing it. 53. Which one are we doing first? Midpoint or the length? So we're going to use the distance formula to find the length, right? Please write down. The problems on the quiz look just like this. They give you 2 points. There's 3 of them. They want you to find the length of the segment. They want you to find the midpoint of the segment. Write the formula down. Then go back and plug in. What's our x coordinates this time?
-2, 6.
Does everybody know that? Ms. Otherson, does that make sense? -2 and 6, the first numbers. -2 minus 6 squared. What's the y coordinates this time?
4.
Don't mess up your signs. This is always a minus sign inside there. If you put a negative in there with it, then it changes and all that, but it's always starting off as a minus sign. What is -2 minus 6? You owe me $2. You borrow 6 to get in the football game tonight. -8. -4. Be careful. What's -8 squared? 64. Positive 64. What's -4 squared?
16.
When you get to this point right here, if you got any negatives left, you messed up somewhere. There should be no more negatives at this point, right? So if Noah's using his calculator there and he punched in -8 squared and it told him -64, he knows that it lied to him, right? What you have to do when you put in that -8, put the parentheses around it before you hit the square. What is 64 plus 16?
80.
Is 80 a perfect square number? No, but looking up here, it's real close to 81, isn't it? What's the square root of 81? 9. I bet this answer is something like 8.9.
Paul, you wait there.
That's real hard to find, isn't it? So if you don't have a calculator, could you make an estimate at least? Yeah. Oh, the other thing I want to say about the calculators. Next week, if you don't have a calculator next week, it goes down as 0 in the grade book every time I walk around and see it.
Did you say that
No.
last
You said
class?
that
Oh,
earlier.
did I say that last
Yeah.
class? So I should check today? I'm not going to. I just give me
No,
a,
last class you said.
Huh?
So happy about getting that grade.
you will next class. All right, so 8.9, are we finished? What else do we still have to find? That's the length of this segment. So that segment's 8.9 units long. Midpoint, write down the formula. Again, if you miss midpoint problems, I just don't understand it. What's our x coordinates this time? If you just write down the formula, I always write down the formula. I do everything else in my head. I don't write down anything else except the answer. But maybe you can't do all that. What's the x coordinates?
-2
-2 plus 6 divided by 2. What's the y coordinates?
0,
Divided by 2. What is -2 plus 6? 4. Still divided by 2. What is 4 divided by 2?
2,
So that's the first half of our answer. What's 0 plus 4?
4,
Divided by 2.
2,
Oops. Sorry, let's do it. What's our midpoint? Over 2, up 2. Does that look like that's probably in there somewhere?
Yeah.
Yeah, it's probably pretty close. Do I do anything after this? Do I add those 2's together or subtract them or anything? It's a point. It's got to come out to be a point. You're looking for the midpoint. All right, on this quiz, you probably need a whole sheet of paper. If you want to use a piece of scrap paper, you can grab another piece up here. I'm going to allow you to work with a partner. Listen carefully. Problems 1 through 3. 2 answers. One of them's find the length of the segment. One of them's find the midpoint of the segment. I highly suggest, because you only got 20 minutes, so you got till 2:02. You and your partner, I would suggest that you do one part, your partner does the other part, then you trade answers. All right? Paige doesn't like that idea, then she should do the whole thing and let her partner sit and do nothing. But she probably won't get finished in time. All right? Problem number 4 is one of the angle problems. Problem number 4 is one of the angle problems. It asks you to find the variable and find the measure of some angle. So you're going to have 2 answers on it also. All 4 problems have 2 answers. On page 36, problems 1 through 4, it's at the bottom of the page. It's not a teacher's book. I don't know.
Yeah.
Get with your partner, don't waste time. Poor Noah here, nobody likes him.
Nobody does.
Nobody likes poor Noah. So he's over here working all by himself.
Good, let him be.
Could Noah turn and ask Anna or Paige or somebody, hey, is this what you got for number 1? And Paige probably would say no, so you might want to turn and ask Anna and see if she would help you. Because Paige is mean.
I know.
You can move the desk around, whatever you need to do to work with your partner. Michael, you understand that, right? You can ask, maybe ask Caleb over here, hey, is this what you got for number 1? I bet Caleb would be nice enough to help you out. The other thing, if you don't have a calculator, you might want to pick a partner that does have a calculator.
Hey, last favor. Grab my calculator on my back.
You really want me your back?
Yeah. Right now, it except books. No,
I'd rather choose the distance
it's in the top one. It's somewhere in there. No, it's in the one you're in.
Again, don't waste time. Help each other, but don't waste time. I'll start counting down. We've got 18 minutes, 49 seconds.
We can just go through everything I got.
18 minutes, 47 seconds. 18 minutes, 45 seconds. Right, we get it.
Quit tormenting us. My brother.
Not the directions, but the points for number 2. Do it quickly or we won't do it. Somebody read me for number 2, read me the coordinates.
6, 4,
Alright, listen carefully and follow along. So if you got any trouble with these, you understand them now. I'll do midpoint first, just because that's easier. Write down the formula. Add the x's, divide by 2. Add the y's, divide by 2. Our x's this time, 6 and 2. Y's this time, 4 and negative 8. I'm going to do the math in my head. 6 plus 2 is 8. 8 divided by 2 is 4. 4 plus the negative 8 is negative 4 divided by 2 is negative 2. That look right? Distance formula. Formula again. X minus x squared plus y minus y squared. X is this time. A lot of people do this, and I don't mind it. X is 6 minus 2. Y's 4 minus a negative 8. 6 minus 2 is 4. 4 squared is 16. These change. 4 plus 8 is 12. 12 squared is 144. Add those together and I get 160. Is that my answer? A lot of people do it this way. What did I forget all the way down through there? The square root. I don't mind if you leave that off because it's just extra writing. But when you get down to the answer, make sure you don't forget to go back and take the square root of 160. What is the square root of 160? 12 point what? 8. Number 4. What number 4 look like?
picture.
I know that. Probably had something like this, right? How many things did it have coming off of it?
3.
Something about like that. I'm going the wrong way.
It's backwards.
So it's down here,
No.
this way.
Yes.
So it's not backwards, it's just opposite there.
Backwards.
Like that? Is that closer?
Yeah.
What'd they tell us?
They gave us letters.
Yeah, just, did they tell us this angle? This angle?
Yes. Yeah.
What's this angle?
2a plus 5.
What's this angle?
3a
Minus 4?
Yeah. And
And
then
then-
both those angles are 11.
They told us all that together was 111. So what equation can I set up?
2a plus 5 plus 3a minus 4 equals 111.
Alright, so watch so everybody understands this. This time we didn't know that these two were equal to each other, but we did know that this and this together totaled up to 111. That's 5a. 5 and 4 give you 1. Equals 111. Subtract 1. Get 110. Divide by 5. A is what, like 22?
Yeah.
Is that our answer?
No.
It's part of it. Then they ask us to
Plug it in.
plug in back in that angle. 2 times
22.
22 plus 5. What's 2 times 22?
46.
44 plus 5.
49.
So that's the other part of our answer. So you should add both those answers, 22 and 49. All right, today is the, what is today, the 5th? 5th, go ahead and start copying this down real quick. We're gonna go very, you want me to make them longer?
No.
Then quit complaining. Angle relationships is what we're going to cover. Be able to name special pairs of angles. What's a pair?
Two angles.
Two. So two. Special pairs of angles. So these special angles, for some reason there's two angles and they're special to each other. Make sure you write your before, after, effort, and then the reflect. Part of your assignment, because I know we're not going to get finished, part of your assignment is to do the 2 or 3 sentences on your reflection of the notes for today. Don't forget to go back and do that. It will be checked next time when I check your homework next time and calculators next time. Be able to find the measures of angles. Be able to identify, when you talked about parallel lines, back in 4th grade or 5th grade, what was the other word that went along with parallel?
Perpendicular.
Perpendicular. That's what that symbol right there means, perpendicular. Parallel lines are two lines that never what? Intersect. That's sort of wrong, but we're not going to go into why that's wrong right now. Perpendicular lines are lines that what?
Make a 90-degree angle.
Intersect to form right angles. Some of the stuff that we're going to go through, when I get to a slide, I'll tell you, you might not have to write it down. Some of you will have to write stuff down. But I'm going to move very quickly, so you need to write very quickly. On this one, don't write this down. Angles, when you have two lines drawn, how many angles are formed?
4.
Always 4. You got two lines that intersect, it's always going to form 4 angles. All right? Maybe they're right angles, maybe they're not. Depends on the picture. My picture here happened to be, I was probably lazy and I just drew them so that they look like they're perpendicular to each other. It's got nothing to do with anything that we're going to cover. All right, don't write this down either. We're going to write down something on the next screen that's going to explain this a little better. Angle 1 and angle 2 are called adjacent angles. They're adjacent. Again, words in here mean the same thing they mean in anywhere in the world. Whose room in this school is adjacent to my room? Mr. Alexander's. We share a what?
Wall.
A wall. These two angles are adjacent, not because they share a wall, because there's no walls and angles, but they share a what? A ray or a side of the angle. All right? Are there other adjacent angles in that picture? 1 and 4,
4 and 3.
4 and 3, 3 and 2, all those are adjacent angles. Now, the bad thing with adjacent angles, let me switch to the next slide so you can start writing it down. This is the definition of adjacent angles. Along with this, I am going to write something else down with it so that you can have it. I always call adjacent angles neighbors. They're next to each other. When somebody asks you who your neighbor is, they're not talking about the person across the street, right? They'd ask you, if I wanted to know who lived across the street from Albert, I'd say, hey, who lives across the street from you? If I wanted to know who lived next to him, I'd say, hey, who's your neighbor, right? Two different things. So adjacent angles are like neighbors. Bad thing about adjacent angles is you're writing this down. Me and Mr. Alexander's room are adjacent. Does that tell us anything about how our rooms are compared to each other or how they're related? Does that mean his room's bigger than mine? My room's bigger than his? They're the same size? It tells you absolutely nothing mathematically when you say these two things are adjacent. All right? And it doesn't have to be angles like this that are adjacent. I could draw a picture like this. Are those two angles adjacent to each other? Yeah, they still share a side. All right? But that tells us absolutely nothing about them. So adjacent angles aren't quite as important as the stuff, most of the stuff that we're going to cover the rest of the class. We already did that. This one, very important. So you might want to put a big asterisk or something beside this, saying, hey, I need to know this. Vertical angles. Vertical angles are non-adjacent angles formed by two intersecting lines. Non-adjacent angles formed by two intersecting lines. What do you think non-adjacent means?
Don't share a side.
All right, they don't share a side. They're not right next to each other. So in this picture, which angles are vertical angles?
1 and 3.
1 and 3,
4 and 2.
and 4 and 2. That's one pair of vertical angles. That's another pair of vertical angles. I start drawing lines that intersect. What looks to be true about these two angles right here? They look like they're the same, don't they? I draw two other lines over here. Two completely different lines. What looks to be true about that angle right there and that angle right there? They look like they're congruent. I draw two other lines. What looks to be true about those two angles? They're congruent. Any two lines I draw, when they intersect, those angles that are non-adjacent to each other, that are across from each other, are always going to be congruent to each other. And that's what else we're going to write right here. Vertical angles are congruent to each other. They're always congruent. That's actually going to be a theorem when we get to chapter 2. We're not going to learn it as a theorem right now. You just need to know that anytime you see two angles that are vertical to each other, they're always going to have the same measure. Vertical angles are always congruent. So what if I told you angle 1 here was 70, let's make it easier. If I told you angle 1 there was 80 degrees, what else could you tell me in that picture? Angle 3 has to be 80 degrees. Now that's not the only thing you can tell me because you're smarter than that. What else can you tell me?
Angle 2 has to equal 180.
Those two angles right there together have to add up to be how much? 180. So what's angle 2? 100 degrees. Well, if angle 2 is 100, what do you know about angle 4? So anytime you see a picture that looks like this and you know one of the angles, you're going to be able to find the other three?
Yeah.
Yeah, it should be real easy. All right? Vertical angles are always congruent. Yeah, we just did that. Just did that. All right, this is important. Also, don't switch on me. Supplementary angles. Some of you probably heard of supplementary angles before. Write this down. I'm going to move this thing if it lets me. That'd be soft with it, I guess. Supplementary angles are two angles that add up to 180 degrees. Two angles that add up to 180 degrees. Notice it says two angles. So it can't be 3, can't be 4, can't be 5, can't be 6. It's two angles that together add up to 180 degrees.
Isn't there complementary?
That was my next thing. When you heard about supplementary at some point, whenever you learned about supplementary angles, you also learned about what other kind of angles? Complementary angles, and that's on the next slide. You've probably seen it when it switched, didn't you? That's why you did that.
No, actually, I was thinking about it because I couldn't remember it. And then
So looking at this picture, name me two supplementary angles in this picture.
3 and
3 and 2. Do those two have to add up to be 180?
2. Yeah.
Yeah. Name me another pair of supplementary. 1 and 4. 1 and 2. 4 and 3. All those are pairs are supplementary angles because we know that they add up to be 180. Now, when you have a picture that looks like this, if I could draw anything straight. Angle 8, angle 9 here. We have angle 8 and angle 9. And I ask you to tell me what special pair of angles those are, what could you say? They're supplementary. Now, not only are they supplementary, but what else are they? What did we say back at the very first slide? They're adjacent. Do they share a side? So these two angles are supplementary to each other. They're adjacent to each other. Which one of those two is going to make more sense to the math class? Saying adjacent? Why supplementary? Because as soon as you say they're supplementary, you know that they add up to be 180. If you just say they're adjacent, does that tell Michael anything when he's looking at them? No, it just says, hey, they're hooked together. But if you tell him they're supplementary, then he knows, hey, they have to add up to be 180. So supplementary is a little more important here. Now, does that mean that every time you see two angles, they're going to be supplementary and adjacent? No, we talked about these two angles. They're adjacent, but are they supplementary? No. So not all supplementary angles are adjacent angles, and not all adjacent angles are supplementary angles. But this next one, anytime you have a linear pair, what that means is you have a pair of angles that together make up a what? A line. Do these two together make up a line? That's called a linear pair. Those are a linear pair of angles. So 8 and 9 are a linear pair. Well, they tell you that 8 and 9 are a linear pair, then you also know that they are what to each other? Adjacent and supplementary. So knowing that something's a linear pair helps you to know that, hey, they have to add up to be 180. Wade, that make any sense? Or did I go too fast on that? A lot of information, right? Now, again, every time something's a linear pair, they're supplementary and they're adjacent. Every time angles are adjacent, does that mean they're a linear pair? No, it doesn't work the other way around all the time. Now, the one that Allison said, complementary. Write this down, draw this little picture. What's that box there? Tell us. It's a right angle, 90 degrees. If I have this right angle, I draw some other ray in here. That ray doesn't have to bisect that angle, but we call this, let's say this is angle 3, this is angle 4 maybe. What do you know about angle 3 and angle 4 together? They add up to 90 degrees. And that's what complementary angles are. Complementary angles are two angles, again, not 3, not 4, not 5, two angles that add up to 90 degrees. I don't know any easy way other than the way I remember it. Complementary, supplementary. Complementary goes with 90. Supplementary goes with 180. I just remember that in the alphabet, C comes before S. In numbers, 90 comes before 180, so that I can remember them. If you come up with a better way than that, somebody last year, yeah, then you just got to remember other stuff though. I'm trying to think of a way that will. Oh, straight. Okay, yeah. So 180, supplementary straight, all S's. I guess that sort of works. Some student last year told me a way to remember it, and I thought, hey, that's pretty good. But guess what happened? I forgot what they told me, so must not have worked too well. So complementary, two angles add up to 90. Supplementary, two angles add up to 180. Look at these two. Give me a special name for these two angles. Supplementary. Give me something else. Adjacent. Linear pair. It's all three of those, right? How about these two? Adjacent and complementary. How about these two? Vertical. All right? Make sure you don't miss that one. If I don't teach you anything else this whole year, you've got to be able to pick out vertical angles. How about these two right here? A little harder. These two angles, what are they to each other? Complementary?
No, supplementary.
Supplementary. Now they're supplementary. Are they a linear pair?
No.
Are they adjacent? No. So they still add up to 180, but they're not hooked together. How about these two right here? I thought I heard it. Adjacent. That's all we know about them, right? We don't know anything else. How about these two?
Complementary.
Complementary. Write this down. Lines that form four right angles are called what? What can we fill in that blank with?
Perpendicular.
Perpendicular. So you got these two lines that intersect. They form 4 right angles. Those 2 lines are said to be perpendicular to each other. The next thing, the symbol for perpendicular. Symbol for perpendicular is this,
Like upside down.
upside down T. All right? So, let me write this up here. This is the way problems are going to look in this book for the rest of the year. Somebody read that statement to me.
Right.
Line AB.
Line AB
Perpendicular with line QR.
is perpendicular to line QR, and they're going to expect that you can draw that picture. So if I draw this right here and say this is AB, how am I going to draw QR? So we want it to cross it so it forms right angles, so maybe something like that. QR. How are we going to let Nora back here know that they were perpendicular?
Make right
Yeah,
angles.
with little squares.
Put a little right angle symbol in one of those. Do I need to put it in all 4 of them?
No.
If that's 90 degrees, what do I know about this over here?
That's right.
It's 90 because they're what kind of angles?
Adjacent.
No.
Vertical. How come? Let's go back to vertical. Nobody knows. That should be the one that you remember the most from the day. What do you know about these 2 angles? Adjacent, and they form a linear pair, so they're supplementary. So it has to be how much?
90 or 90.
90. This one up here, 90, so on and so on.
No.
Let me draw one more picture. What kind of angles are those 2 angles right there?
Vertical.
Thank you. Yeah, we're skipping that. Let's skip that too. Can you tell me about these 2 angles before I go on? Ah, they were what? What are they? Complementary because they add up to 90. Do they have to add up to be a right angle? No, just 90 degrees. How about these 2 angles right here?
Adjacent.
They're adjacent. What else? They're complementary because if this is a right angle over here, what's this whole thing over here got to be?
90.
Right angle. Oh, you know what? I forgot to fix this. I got messed up in one of my classes earlier and I forgot to fix it. That means I'll write it down here for you. Page 42, 12 through 34, the even numbers. 41 to, what is that, 43? And 50 and 56, does that look right?
Yeah.
I think that's right. Gotta remember to fix that. Don't forget also, you got about 3 minutes. You could probably do it right now. Do your reflection in your notes. Write 2 or 3 sentences. That way you don't forget about it. Get that done right now before the bell rings.
Good afternoon, everybody. Time for Friday afternoon announcements. Obviously, good luck tonight to our football team as they will travel to Miami East for tonight's game at 7:30. Good luck this weekend to our cross-country teams as they travel to Brookville for an 8 a.m. match. And also good luck to our golf team, Tri-Village, and our girls volleyball at Eaton and girls soccer in Miami Valley. So good luck to all of our athletes this weekend and tonight in competition. Reminder, all students, picture day will be next Tuesday. Please make sure the forms get home. Seniors, reminder, your picture day will be on October 24th. And I do believe those are all the announcements we have for tonight. Everybody have a great weekend, and we'll see you back here on Monday.
first one, these angles, they form a line, so they're a linear pair. Well, they also share a side, so they are adjacent. I'm not gonna write all these words out. They're adjacent angles, but since they are a linear pair, they're also supplementary because they add up to be 180, which is that straight angle right there. The second one just tells us that's a right angle. So we know that these angles are complementary to each other. And we also know they share a side, so they're also adjacent. These two down here, not neighbors, they're non-adjacent to each other, so that means they have to be vertical angles. Again, that's probably vertical angles, one of the more important ones. This one, just going through some of these, we have all kinds of angles in this first picture. Okay, we'll go back. These angles, you have certain angles, they're adjacent, supplementary, linear pair, so on and so on. These two, since they share a side, we know that they're adjacent, and that's the only thing that we can say about them. These two, even though they don't form a right angle together, we look at their measures, they add up to 90, so they are complementary angles. These two down here, we add them up, they're supplementary angles. Now they don't form a linear pair, and they're not adjacent angles, so we can't say any of that. These, again, are adjacent, supplementary, and they're also a linear pair. So whenever you see a picture like this one, a lot of information that you know about that certain picture. Again, lines form for right angles, called perpendicular lines. Symbol for perpendicular is that upside down T. You see something like this, AB, line AB, that symbol, line PQ, that's red. Line AB is perpendicular to line PQ, which means they come together to form right angles. All right, on this example, it's one of just a practice example. We'll look at this down here at the bottom. It tells us line FC is perpendicular to line AE. So this is AE down through here, FC is across through here. That means all these angles, all the way around there, are right angles. Now you gotta be careful because you have this extra couple of rays that they stuck in there. First thing, we can figure out what X is right here because we know that this angle over here is 5X plus 10. Well, we also know that this angle is a right angle, so that 5X plus 10 has to equal 90. Subtract 10 on both sides, you end up with 5X equals 80. Divide by 5, you end up with X equals, 5 will go into 8 once, 30, so X equals 16. Over here, we look over here, they tell us that that angle right there is a right angle. Well, then that means these two angles have to be complementary to each other because they have to add up to be 90. So we can set up 16y minus 4 plus 2y plus 13 equals 90. And we solve that, that's 18y, just collecting like terms, plus 9 equals 90. Subtract 9 on both sides. 18y equals 81. Divide by 18. I don't have a calculator here, but I don't think 18 will go into 81 evenly. But what I can do is reduce it down to, I know 9 will go into 18 twice. I know 9 will go into 81 9 times. So y is 4.5 or 4.5. And that's all they wanted us to find was X and Y. Now, we could go back and plug each of those in to find all the angles here. If we plug in right here, 2 times 4.5 is 9, plus 13 is 22. So this angle is 22 degrees. Well, if this angle and this angle have to add up to be 90, and this one's 22, we just take 90 minus 22, and you get, that's 8, had to borrow there, 68 degrees, so that's this angle up here. Well, this angle over here has to also add up with this one to be 90, so it has to be 22 degrees. This one down here has to add up with this one to be 90, so this angle would have to be 68 degrees. Now my picture isn't drawn to scale, so it doesn't look quite right. We know that both these angles are already 90, so we don't really need to do anything to those. All right, this picture is for page 42, problems 11 through 16. We're just going to go through these real quick. Number 11 says, name 2 acute vertical angles. So in this picture, we want 2 acute vertical angles. If I look right here and right here, these 2 angles are vertical to each other, so I just have to name them. So angle WUY, that's this angle right here, and angle VUX. Make sure you're using your symbols. Number 12 says name 2 obtuse vertical angles. Well, if these 2 were acute, then that probably means these 2 over here are obtuse and they're vertical to each other. So that's angle WUV and angle WU, and you could use either T or Y as that second letter. It makes no difference, it's still the same angle. 13 says name a pair of complementary adjacent angles. Complementary adjacent angles means that they have to add up to 90 and they have to share a side. Well, if I look up here, that angle is 90. These 2 over here then together have to be a right angle, and they share a side, so I can just use those 2. YWT, so angle YWT, and angle UWT. Those 2 angles right there, they add up to be 90, so they're complementary, and they share a side, so they're adjacent to each other. Number 14 says name a pair of complementary non-adjacent angles. Complementary non-adjacent angles. Well, if we look at these measures right here, this one's 30 degrees, that one's 60 degrees. That adds up to be 90. So it'd be this angle down here at the bottom, which we'll call angle BXU. And this angle up top here, which is angle WYT. And again, there's different ways. We could have named this top angle up here angle ZYB or whatever. There's a whole bunch of different ways to name it than what I named it, as long as Y is the vertex, is in the middle. Number 15, name a linear pair whose vertex is T. Vertex right here is T. We want a pair that together form a line. Well, these 2 form a line together. The bad thing is there's no letter out here to help us name it. So instead of using those 2, we'll use these 2 over here. That'd be WTB. So angle WTB and angle WTY. Number 16 says name an angle supplementary to UVZ. UVZ is that angle right there. We want an angle that together with that adds up to 180. Well, it's going to be this angle over here that forms a linear pair with. That's angle UVX. All right, this is your in-class assignment. If we had time to do it, we'd probably do some of these together. Try them. And this is your assignment.